All right, I have another example here of integration by parts, again with a little mini substitution to get it started at the beginning. Again, if you try to do this by simple integration by parts or substitution by themselves, they do not work. You get a confused mess. But with an initial substitution, in this case, noting that you got x squared and x to the or t squared and t to the third here, if we kind of separate this and think of it as t squared times e to the minus t squared and then t dt, that kind of helps us see that if we say let x be equal to t squared, right, then dx is equal to 2t dt, and I've got this t dt part down here. So I'm going to write this as 1/2 dx is equal to t dt. You know to do that a little bit by trial and error, but you can't really start off with this kind of substitution, take the derivative, and then get a piece up there because there's no way to get the dt up there. So really you have very few options, and try that and see what happens. And when we rewrite this then becomes the integral, well, t squared is our x, then our t dt is right there as our dx. Don't forget the 1/2 out front, and then this is just times e to the minus x then, because x is t squared. This we can work at now by integration by parts. So I'm going to down here do my little u substitution, where u is going to be equal to, which do I start off with? Well, this is where we consult the holy orders of Lie and see that logs come before inverse, trig comes before algebra, comes before trig, and very last in our priority list is exponentials, and there's an exponential. So we're going to do this first. U equals x du equals dx, working down, then working up on this side, dv is going to be equal to this part here, e to the minus x dx. And then I integrate to find what v is. V then is just minus e to the minus x. Okay? Well, we know then this is going to be equal to our integration by parts formula of uv minus the integral of v du. So putting that into play, I've got x. I'm going to pull the minus sign out front, e to the minus x. I think the thing you want to pay attention to is just not losing track of these minus signs. Ooh, and the other thing you really do not want to lose track of is that 1/2. So let me see if I can sneak that there. I'm going to brush this back, turn this into a 1/2. That is some skill there. And I'm not going to lose that minus sign. Then that's the u times the v part minus the integral of, there's the minus and a minus. I'm going to pull that out carefully right there. E to the minus x, and then just dx. Okay, there it is. What happens next is I am going to go with 1/2, then minus x e to the minus x. When I integrate this, I get minus e to the minus x. That's a lot of minus signs. If I pull out the minus e to the minus x, maybe that's easier. Minus e to the minus x over 2 times then x plus 1. And don't forget the plus c. There we go. Good luck in the rest of it.